Hello students, today we will learn about the relative velocity concept. The relative velocity of an object 2 with respect to object 1 when both are in motion is the time rate of change of position of object 2 with respect to that of object 1. Let's study this one in detail. For that, consider two objects A and B moving with uniform velocities VA and VB along two straight and parallel tracks. Let us suppose that at the starting time, means at t is equals to 0, x naught A and x naught B, the distances of the bodies A and B, and after time t, xa and xb are their respective distances from the origin. That means xa will be equals to x naught A plus VA into t. Similarly, xb will be equals to x naught B plus VBT. On subtracting the two equations, we will get xb minus xa and the term VB minus VA in the right side, and this term VB minus VA is the relative velocity of object B with respect to object A. Similarly, VAB will be equals to VA minus VB, and from that equation, if we have to find out VA minus VB, then it will be XB minus XA minus of the term divided by T. That means it will be the relative displacement upon time, and so it is called the relative velocity. Remember that if you have to write the formula for relative velocity of object 1 with respect to 2, then it will be V12 equals to V1 minus V2. And similarly, the relative velocity of object 2 with respect to 1 will be V21 equals to V2 minus V1. And this clearly shows that V21 is negative of that of V12. Now let's understand the concept of relative velocity in more detail in terms of position time graphs. You know that position time graph slope gives us velocity. See the first figure. In this, the two straight lines are parallel to each other. That means the position time graphs for the body A and B are parallel. So you can say that their slopes are equal and their relative velocity will be 0. That means VB will be equals to VA. In the second case, the position time graph of object A slope is more than that of B. That means VA is greater than VB, and hence VB minus VA will be negative. Now in the graph, a situation is shown where the two objects have velocities in different direction, and the velocity of one object with respect to another is 30 meter per second. Just like the situation for a person sitting on either of the two trains and the other train seems to go very fast. Now let's understand a numerical problem based on the same topic, relative velocity. Here the question is, two parallel rail tracks run north-south direction. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. You have to find velocity of B with respect to A. Second, velocity of ground with respect to B. Third part, velocity of a monkey running on the roof of the train A against its motion, and it's given that the velocity of 18 km per hour with respect to train A as observed by a man standing on the ground. So it's given that VA is 54 km per hour. First convert it into meter per second. Similarly for VB, because it is moving in the opposite direction, so you have to take minus 90 km per hour. So for first part, relative velocity of B with respect to A will be VB minus VA, and that will be equals to, by putting the value, you got minus 40 meter per second. That means the train B appears to A to move with a speed of 40 meter per second from north to south. Now you have to find relative velocity of ground with respect to B, and that will be equals to 0 because the velocity of the ground is 0 minus VB. So you got 25 meter per second. For the third part, let the velocity of monkey with respect to ground be Vm. Therefore, the relative velocity of monkey with respect to A will be Vm minus Va. And by putting value, you got minus 5 meter per second. Therefore, Vm will be equals to 15 minus 5. That means 10 meter per second. Now, another problem. There are two towns A and B connected by a regular bus service, with a bus leaving in either direction after t minutes. A man cycling with a speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in the opposite direction. What is the period T of the bus service, and with what speed do the buses ply on the road? Try to solve it first and then compare your solution with the slide. Here you have to use the concept of relative velocity, right? And by finding the value of relative velocity, then use the formula of velocity equals to displacement upon time. You will get the time. Thank you.